Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, Chapter 11.5, Budget Matrices. Matrices, what's a matrix? The objective of this lesson, the objectives are: 1, determine the dimension of a matrix. Subtract and multiply matrices, and multiply a matrix by a scalar. Okay, so those are the objectives of this lesson. And over here on the right in this red square, I have all the definition, the words that we need to know the definitions of, the vocabulary. So what is an array? Well, for starters, an array is an ordered arrangement, and it doesn't have to be numbers, it can be anything. Just as long as something is put in some sort of order, that is considered an array. So here I have an example from the book. This is a clock. That's an ordered set of numbers from 1 to 12 arranged in a circle. So that is an array. This is Pascal's triangle. That is an array. This is a completed Sudoku board. Sudoku. So Sudoku boards are also arrays, an arrangement of numbers. They're not in any order. Well, they kind of are. No number repeats in any row or column. So those are arrays. All right. Now there's calling a rectangular array. Well, a rectangular array is what we've been working with. If you followed any of my other previous videos from this chapter, if you do a spreadsheet, that's a rectangular array. Any chart or anything like that is considered an array. Okay. So this right here is a chart. It's got 4 categories: income and 3 months, and then some values. So that is considered a rectangular array. That's an example of a rectangular array. So what is a matrix? Well, it's a special type of rectangular array, but it's not going to have any of these words or categories. It's just going to have the numbers. So a matrix, here is an example of a matrix. So all they did was said A equals, and notice the 4,500 goes here, 5,000 is here, 350 is here, 1,200 is here. This is just the same exact order. So if all I had to do is put brackets around here, and that is a matrix. Okay, all numbers in a certain order. So that is basically a matrix. Okay, a budget matrix is a rectangular array of budget entries. So this is a budget matrix. Okay, so there we go. And then we have dimensions of a matrix. Well, matrices have rows and columns. So rows go this way, and columns go this way. So this position right here is row 1, column 1. So that'd be 1, comma 1. And you name the array, A subscript 1, comma 1 is this position. But if I changed positions and I wanted well, this has 4 rows and 3 columns. So it is a 4 by 3 matrix. So that is the dimensions of a matrix. So this matrix here is an A, we would call it A sub 4 by 3. Okay, 4 rows, 3 columns. So then if I went to any entry or element that is anything in here. So if I move this box down to here, that'd be row 1, 2, 3, and then over to column 2. So that is position 3, comma 2. Okay, fairly simple. And so each one of these is considered an entry or an element. So these two things really mean the same thing. And then a zero matrix is a matrix that just has zeros in it. Okay, so here are 3 matrices, A, B, and C, and they're all 0 matrices. So let's just practice a little bit here. There is 1 row, 2 rows. So A is a 2. Actually, I don't want to do a sub. That would list a position in. If I wanted to tell what this dimension of this matrix is, it would be 2 rows by 1 column. 2x1 matrix. This one has 1 row, 2 rows, so it's a 2x1 column, 2 columns. This is a 2x2. This has 1, 2, 3 rows, and it has 1, 2 columns. So here's a 2x1, here's a 2x2, and here's a 3x2 matrix. So there's all kinds of 3x3, 3x4, 4x3. It just depends on what you're doing with the matrices, and that determines its dimensions. Okay, so zero matrix is just simply a matrix that is just all zeros. And then there's corresponding elements. I will skip that for now. It will be in example 2. Scalars and scalar multiplication will be in example 3. So there we have it. There is our objectives. There are our objectives and vocabulary for this chapter. Okay, example 1. So over here, I have that same example from page 1. This is a rectangular array, and this is a matrix of that array, just the numbers from there. Okay, so using Enrique and Sophia's income budget chart and the budget matrix A, where A equals these values from this chart, identify the income budget category for each of the following elements. Okay, so A sub 2 comma 2 means to go down to row 2, column 2, and that would be this value right here. Okay, that is row 1, row 2, row 3, row 4, column 1, column 2, column 3. So let me label those just so we get comfortable with that. So this is going to be R1, R2, R3, R4, column 1, C1, column 2, and column 3. So we always do row first, column second. So row 2, column 2, 5,000. Okay. And then we're going to do the same thing over here. And so that is row 2, column 2. That is this right here. All right. Let me just change that to red so they match. Okay. So this 5,000 came from right there. So it says to identify the category. So the answer to this is you would say A sub 2 comma 2 is the element in the second row and second column. The $5,000 there represents Sophia's February income. Okay, so I'll write that. A2 sub comma 2 is $5,000, and it is Sophia's February income. Oops. Okay. Keep it all color coded. So there's A2 sub 2. And now I'll go to the green for the next one. Let's use green. Okay. Okay. So now it says, one moment, there we go. A1 comma 3. So let's choose this. A1 comma 3 is going to be get out of my way. A1 comma 3 is right here. It's not letting me do what I want to do, so I'll just have to change it after. All right, so here's 1 comma 3. Row 1, column 3. Change the color to green and do another rectangle, and that was over here. Right there. Ready? Oops. Okay, so now we're going to answer the question. What is that? Well, A1 comma 3 equals $3,500. And that is Enrique's March income. Okay, and then the last one we'll do in purple. So the next one says A4, comma 1. So let me get my square here. Row 4, column 1 is right here. And we're also going to draw that. That ends up being right here. And so A4, comma 1 equals $1,200. And that is rent from their tenants in January. So I'll put January tenant rent. Okay, so there's the answer to example 1, just to give you a feel of positions in the matrix, and those are called the dimensions. So you need to know the dimensions there and the location in those, okay, where the element is. All right, so now let's check your understanding. So try to do this on your own, pause the video and then come back. And it says, suppose Enrique and Sophia's income budget chart and matrix had started with the column labeled December. So what they're saying here is we're going to put another column right here and call it December. So December would come right here and then be another column right here with December in it with values. Okay, and it still has entries for January through March. If the new income budget matrix is labeled B, what are the dimensions of B? So B would be, now we still have 4 rows. So B would be 4 by, but now we have 4 columns, December, January, February, March. So now it's a 4 by 4 matrix. And it says identify the income budget category for each of the following elements: B2, comma 2, B1, comma 3, and B4, comma 4. So let me just create a matrix for that, and then we will answer that with a matrix with new values. Okay, so here's what I did. All I did was took matrix A, widen the brackets, and put a new column in. So this would be December, January, February, March. We already had January, February, March, and I just put A, B, C, and D for values because we don't have a dollar value for any of these. And now it's saying, where's B22? Well, that would be row 2, column 2. So it is going to be 22 is going to be this one right here, which is January, $5,000, because January was column 1, now it's become column 2 because December is before it. So it would be Sophia's primary income for January. Okay, is that $5,000? Did I move this? Yeah, I did. This is not here, it's right here. This is column 1, so let's label that. Column 1, column 2, column 3, column 4, row 1, row 2, row 3, row 4. Okay. So 22 is row 2, column 2, $5,000, which would be this one right here. So it's Sophia's primary income January. Sophia's primary income January. B13 would be row 1, column 1, 2, 3, which is this $5,200, which is right here. And that's Enrique's primary income, which is $5,200. So that's the answer to B1, comma 3. And then finally, B4, comma 4 is row 4, column 4, which is $1,200, which is actually way over here now. And it's the rent from the tenant in March, $1,200. Okay, and that's the answer to check your understanding. Okay, example 2. Enrique and Sophia keep individual expense budgets charts for major categories in their budget titled work-related expenses. So we have here is Enrique's work-related expenses, and here are Sophia's work-related expenses for the months of January through March. So they have transportation, supplies, clothing, and cell phones. They both have the same categories. They both have the same number of months. So if you were to focus on just the numbers like this, this would be a matrix for Enrique, and this would be the matrix for Sophia. It says to set up a matrix that we're going to call E, which represents Enrique's work related. So this would be right here. And there's the answer. And it says to set up a matrix for the first 3 months of the year and a matrix S, which will represent Sophia's. So all you have to do is say S equals just these numbers. So I have done that already right here. And so E equals just the numbers and S equals just the numbers. Okay. Now it says determine matrix J, whose entries contain their combined work-related expenses. This is called matrix addition. So when I work with my students, I always tell them, write a formula. So we want matrix J, and that is going to equal matrix E, Enrique, added to Sophia's expenses. So here it is. Here is the equation. J will equal Enrique plus Sophia's work-related expenses to make a joint amount of expenses called matrix J. So in matrix addition, what you have to do is you have to add your corresponding elements. Okay. So if we're going to take E plus S, what we're going to do is add this to this. Okay, so I'll show you what that will look like. Okay, so here's what it would look like. All you do is take the E matrix, which is here, plus the S matrix, which is here. Okay, and now all we have to do is look at corresponding components. So elements. So row 1, column 1 is 478. Row 1, column 1 in Sophia's is 220. And what you do is you add the components that are in the same location. So this is going to become J equals 478 plus 220. So I would do this, and 0 plus 8 is 8. 2 plus 7 is 9, and 2 plus 4 is 6. So I got 698 here. Notice 478, 478, 478 is the same. 220, 220, 220 is the same. So then what we would do is the next one is row 1, column 2 plus row 1, column 2. And we're going to get that same 698. And then row 1, column 3 plus row 1, column 3 would give us 478 plus 220, which will also give us 698. And that is going to be our new matrix addition. And we continue that with all of them. So it's going to be 30 plus 10, which is 40. 50 plus 10, 60. 30 plus 10, 40. 80 plus 120, 200. 50 plus 120, 170, and 50 plus 120, 170. 40 plus 30, 70, and 40 plus 30, 70, and finally 40 plus 30, 70. So the new joint matrix would look like this. Combined expenses for 3 months for the two of them. Okay, pretty simple. Now what I need to explain to you though is in matrix addition, this is a 3x3 matrix, and this is a 3x3 matrix. In order to add, your dimensions must be equal. I cannot add a 3x3 to a 3x2. I'll have one column that I can't add anything to, and it can't be done. So make sure that they have the same dimensions, or else we're not adding. Okay, so there is a misprint in the book I wanted to point out, and I will just bring that in real quickly from here. This is on page, okay, so here's what the book says. Let's make this smaller so we can read it. This is for any teachers who might be watching this as well. This is page 703 in the textbook. It says, since they have the same dimensions, entry E4, 2, 4 corresponds with entry 4S4, 2, 4. And the two entries are in the same location in their respective matrix. Well, there isn't 3 dimensions in matrices, so this 4 should not be there. Right. What they're saying is E4, 2, which would be row 4, column 2 is right here, corresponds with entry S4, 2, which is right here. There is not another 4 at the end. matrix dimensions are row by column, and there should only be two numbers here. So that is a misprint in the book, just so you know. And now I will continue on to the check your understanding. And it says, does the commutative property of addition hold for matrix addition? That is, given the matrices above, is E plus S equal to S plus E? So I'm going to do that. I'm going to take E, and I'll just bring it down here now. Here's E, and I'm going to add it to S. Okay, so here's E plus S. This is E, and this is S. Well, if I look at this position, it corresponds to this position. Well, if I do it the other way around, and now this is E here, and this is S here, and I put a plus sign in between, and now I have S plus E. Well, the first position plus the second position, or I should say row 1, column 1 plus row 1, column 1 of the second, 220 plus 478 is going to give you 698. 478 plus 220, 698. Since the locations correspond, the corresponding entries, doesn't matter what order you add them, they will be commutative. So does the commutative property of addition hold for matrix addition? And the answer is, I was almost going to write it no. It is yes. Yes. Commutative property of addition holds for matrix addition. Okay, so moving along to example 3, but before I do, let's just recap. Okay, so we know what a matrix is now. Okay, it is an arrangement of numbers. It's an array of just values, number values from a rectangular array. And the matrix has dimensions. So now you know that the dimensions are row by column. And then when we add matrices, the dimensions have to be equal, and you add the corresponding positions in each matrix and get a sum for the new matrix. Okay, so we know how to do dimensions by row and column, and we know that the dimensions have to be equal when adding, and addition, matrix addition is commutative. Okay, so that's what we've learned so far. But now we're going to do multiplication. And it says, Sophia will be doing a great deal of work related travel around the country during the months of April, May, and June. She estimates her work-related expenses will be 3 times what they are for the first 3 months of the year. So we're taking the first 3 months of the year from this list right here. Those are her first 3 months. So that's basically our matrix S. Okay, and we're going to, and she thinks it's going to be 3 times that for the next 3 months. So it says to determine Sophia's work-related expense budget matrix for April, May, and June. So this is called scalar multiplication. And so for starters, it would look like this. W, why do we name it W? Work-related travel, so W equals 3 times Sophia's from January, February, March. So you're just multiplying the whole matrix by 3. So I brought the matrix in. This is matrix S. So I'll label that S up here. This is matrix S. And scalar multiplication would look like this. You'd say W equals, and you just put a number in front. So 3 times this, it's like a variable 3x. You know that something right next to something means multiplication in math. It's the same with a matrix. 3, and then in front of a matrix means 3 times it. And what's going to happen is you're going to get a matrix, and you're going to take 3 times 220. You're going to take 3 times 220, and all you're doing is multiplying every single element of the matrix by 3. It's a very simple process. And this is 3 times 10, 3 times 10, 3 times 10. And this one's 3 times 120. Back. 3 times 120. 3 times 120. 3 times 120. The bottom row is 30. So it's 3 times 30. 3 times 30. And finally 3 times 30. Okay, it's more work writing it out than it is actually getting the solution. And so now W is going to be over here, and it is going to equal a matrix that is 3 times 220, which is 660, 660, 660. And this is going to be 30, 30, 30. 3 times 120 is 360, 360, 360. And finally, 3 times 30 is 90. 90. Okay, so there is our matrix scalar multiplication. So now W equals this right here. So she plans on spending $660 on, and if we go back, we can look, transportation. She plans on spending $30 on supplies. She plans on spending $360 on clothing and $90 on cell phone. Okay, so now we're on to check your understanding. And so now it's your turn to see if you understand this concept. And it says Sophia's employer will reimburse her 80% of all work-related expenses for the months of April, May, and June. So this is April, this is May, and this is June. Let matrix B represent the matrix of expenses covered by Sophia's employer. Determine matrix B. Okay, so here we go. B is going to equal 80% of this W. So B is going to equal 0.80 W. That makes sense to you. And then now we're going to fill in. So it's going to be B equals 0.8. I'll just drop that 0. And then it's going to be times 660, 660, 660, 30, 30, 30, 360, 360, 360, and 90, 90, 90. Okay. So then we're just going to do the multiplication. So it's going to be 0.8 times 660 and hit enter, and I get 528. So it's going to be 528, 528, 528. And then it's going to be 0.8 times 30. That's 24. 24. And 0.8 times 360. That's 288. 288. 288. And 9 times 8 is 72. 72. 72. Okay, so there's that. And since I just used my calculator, here is a good place where I'm going to show you how to do matrix multiplication and matrix addition and all of that in your calculator. So now I'm going to go back, and I should have done this before, but I want to do this matrix addition here. So I'm going to turn my calculator on. And if you have a TI 84 or 83 calculator, you can do matrices in them. So if you look over here in blue on my calculator, it says matrix. That means to use the second button. If you have a different calculator and this button is yellow, then this word matrix will be in yellow. So you hit second matrix, and then they've already put 10 in the calculator all the way up to J. And there's names, there's math, and there's edit. So here's A. And we can go over and we can edit it. And we can call it matrix A. And what I'm going to do is enter this 220, 220, 220. This is actually S. So it is a 4 by 3 matrix. So it asks you what the dimensions are. So it's a 4 by 3. And that automatically creates a 4 by 3 zero matrix in your calculator. Matrix. But now I want to put 220. So I enter 220. Okay. And then want to enter 220 in each one. So 220, enter, and 220, enter. And then the next row is 10, 10, and this is how you enter it in your calculator. And then we want 120, 120, 120, and then the last column is 30, or row, last row is 30. Okay, so there's matrix A. So we're done entering matrix A. So when I go back and hit second matrix, so now it's saved it. It says it's a 4x3. And now I want to edit matrix B. So I'm going to go over to edit first and then down to B. And B is going to be our E, if you will, unless you want to just go down to E and use that one. I didn't rename A S. We will know that A is representing S, but here is matrix E. It is also a 4 row by 3 column. So it's 4 by 3, and there's our 0 matrix. And this one is 478, 478, 478, and then 30, 50, 30, and then 80, 50, 50. And then finally 40, 40, 40. Okay, so I have now entered matrix A and E in the calculator where A is S, just so you know. And then I'm going to go to my home screen. And just to show you that it's going to get put here. So I'm going to go like this. I'm going to go second matrix. And I'm going to choose A. So I just hit enter. And I want to hit plus. And I hit second matrix 5 for E. So this is going to take matrix A plus matrix E. And when I hit enter, I'm going to get my 698, 698, 698, 40, 60, 40, 200, 170, 170, 70, 70, 70. Boom, just like that. There is your matrix addition. So now I'm going to prove to you that matrix addition is commutative. Now I'm going to do it backwards. Second matrix. I'm going to take 5. I'm going to add it to second matrix 1. E plus A, and I hit enter, and it also gave me the same values as the other way around. Okay, so now I'm going to go back to the matrix, and let me go back to this page here, and now I'm going to show you the scalar multiplication of this 220, 220, 220, and how to do that in your calculator. So let's call this matrix, it doesn't matter, let's put it in B. So I'm going to, first I want to go up to edit. And actually it's A, isn't it? So if I look at A, yeah, that's the 220, 220, 10, 10, 10, 120. So matrix S is already here, and I want to take 3 times S, which is our A. So if I go back to my home screen and clear it, I'm going to do 3. I'm going to hit second matrix A. Hit enter. And just like that, we got 660, 660, 660, 30, 30, 30, 360, and 90 in the bottom row. Okay, so there's scalar multiplication in matrices in your calculator. Pretty cool stuff. Okay, so now let's do extend your understanding. Okay, and well, actually, let's do this one too while we're at it. So now we have this matrix here, 3A. So now I can take 0.8 of that. So if I now wanted to create a matrix, push the wrong button there, clear, second matrix, and I want to edit, enter, and let's just now, whoops, second matrix, over to edit, let's put it in B. So let's call B this new matrix 660. It's still a 4x3. So you do your matrices and then you get your 0 matrix. And now we want to enter what we got, which was 660. Enter. 660, 660, 30, 30, 30, 360, 360, 360, 90. 90. Okay, go to second home, clear, second, whoops, 0.8, now I'm multiply by 0.8, second matrix 2, enter. And there's my 528, 24, 288, 72, just like that. Really nice doing these in the calculator. Now it says to extend your understanding. Let matrix C represent the amount that Sophia will have to pay out of pocket for the work-related expenses from April to June. C can be determined by matrix subtraction, which is C equals W minus B. So we want to do C equals W minus B. So C is going to equal W. What was W? It was 3S. So that's the 660, 30, 360, 90. Okay. W is 3S, and B was the 80%. So W ended up being 660. It's this matrix here. So let me just copy that. So we're going to take this matrix right here, and that's my W. Okay, so there's W, and we're going to subtract B, which was 80% of W. So now we're going to subtract this. Down to size there. Okay, so then C is going to be, this is scalar subtraction. Or not scalar subtraction, this is matrix subtraction. So we're taking W minus B. And W 660, 330, and then the 528. So if I go into my calculator and hit clear, and go back to my matrix and look at them, okay, I don't want A. B is 660, 30, 360, 90. So there's my B. So B is actually W in this case. All right, so I'm going to take that and I'm going to hit minus. So there's my matrix minus, and my, where was my 5W? Was it this one here? Second matrix 5. So what is E? I can't remember what E looked like. So if I, let me clear this first. So if I want to look at E, is it these values? No, it's not. It's not that. It's not 528. So clear. So go to my matrix. So it's a good idea just to put these in order. So if I just want to go over to edit and look at them first, I'm not using this one. $660, 30, 360, 90 is my, it's called B in the calculator, but it is my W in this problem. And then I want to go look at this one, and it's not that one either. So I need to create one. We haven't entered it as a matrix. So I'll put it in C. First, down to C, enter, and it's a 4x3. And I want to enter 528, 528, 528. Oops. Cancel. 528. Enter, and 24. Enter 24, enter 24, enter 288, enter 288, enter 288, enter 72, enter 72, enter 72, enter. Oops. Right, 72, enter 72. All right, so there is the second matrix we want to subtract. So I'm going to take B, matrix B. Let me clear this. Second quit. Okay. I'm going to take second matrix B minus second matrix. And I put it in C. And I got 132. 6, 72, and 18. Okay, so I'm just going to enter those in 132, 6, 72, 18. Okay, so it was just 660 minus 528 gives us 132, 30 minus 24 is 6, 360 minus 288 is 72, and 90 minus 72 is 18, but we can do it all in our calculator as well. Okay, so now we have to do this C equals 0.2W. This is scalar multiplication. So here we go. And we're going to take C equals 0.2 and bring our, I just copied it down. And I'm going to bring it down and just resize it like so. So 0.2 times that, and that is going to equal, and if I go into my calculator and if I look for that matrix, it was. I have to go over to edit to look at it and go to C. No, I want the 661 second matrix. Go over to edit. Maybe it was B. And there it is, 660, 33, 60, 90. So I want to take 20% of matrix B. So I go to my home screen and I take 0.2 second matrix 2. So it's 0.2 of B and hit enter. And notice I got the same answer as here. Okay. 132, 6, 72, 18. So obviously, if you're going to take something and subtract 80% of it, it's going to be the same as multiplying it by 20%. Okay, so scalar multiplication can also be equivalent to a scalar subtraction. Okay, so now we know what a matrix is. We know its dimensions. We know that if two matrices have the same dimensions, we can add them with corresponding elements. We now know that we can multiply a matrix by a number. It's called a scalar multiplication. This one is going to be multiplying two different matrices to get a product matrix. So example 4 says, as listed in their budget chart, Enrique and Sophia have secondary income from the online sale of customized cookies, cakes, and cupcakes. They want to determine the monthly income from sales based on the data they have collected at the end of the year, as shown in these two charts. So the month is October, November, December. They have cookies, cakes, cupcakes, and a quantity, and there is our number matrix. So 65, 65, so it's just the numbers from here. And then we have an item price matrix. So it says to set up a number purchased matrix. So there it is. Those were the number of cookies, cakes, and cupcakes in October, November, December. And this is the price matrix over here. Okay, so this is a 3 by 1, and this is a 3 by 3. So I'm going to write that under here. Every time you do a multiplication matrix, you should always identify the dimensions. And the reason is, if the inside numbers that you're multiplying are the same, they can be multiplied, and the outside number is going to be the dimension of your new matrix. So when I multiply these, I am going to get a 3 by 1 matrix. So here is the rule over here. Let me bring it up. And it says, if we have a matrix A with a dimension of m by n, and we multiply it by a matrix B, n times p, the n's have to be equal. The middle must be equal. This has to equal this, and we will get the outside dimension as our new product matrix. And that might be a little confusing at first, but it's really not that bad. So let me now just scroll up here. Use matrix multiplication to determine the income from each item. So here's what we have to do. We have to take row 1 and multiply it by column 1. So you're going to take 65 times 3. So this is going to, it says use matrix multiplication to determine the income by each month. So n times p is going to equal, and here's what we do, 65 times 3, I'm just going to show all of my work, plus 40 times 30, plus 75 times 5. Okay, so what we're doing is we're, think of this 65, 40, and 75 being rotated and put here, here, and here. So you're just taking this matrix over here and rotating it so it lines up, and you're multiplying those values. Okay. Oops, I didn't want to erase that. It is a 3 by 1. Okay, so that's that. So then we're going to go on to row 2, which is right here, and take the first position times the first number. So that's going to be 80 times 3 plus 70 times 30 plus 150 times 5. And then finally, the row 3 is going to be multiplied by column 1. 120 times 3. Actually, let me erase those first. So 120 times 3 plus 200 times 30 plus 300 times 5. Alrighty. So that is going to equal 3 times 5 is 15, carry the 1, 6 times 3 is 18, plus 1 is 19, so that's 195. So this is a little bit lengthy process. We still have to add these. 4 times 3 is 12 with 2 zeros, plus 75 times 5. 5 times 5 is 25, carry the 2, 35 and 2 is 37. And I get 375. So now I'm just multiplying these. 8 times 3 is 240. 3 times 7 is 210. Another 0, 21. 5 times 0 is 0. 5 times 5 is 25. Carry the 2. 5 times 1 is 5. Plus 2 is 7. Okay. And then 3 times 120 is 360. Plus 3 times 2 is 6 with 3 zeros. Plus 5 times 3 is 15 with 2 zeros. And finally, we add these all up and we get a sum. 5 plus 0 plus 5 is 10. Carry the 1, 7, 8, 0, 8, 9 is 17. Carry the 1, 4, 5, 6, 7, and then 1. So we got our first answer here. Okay, so they made $1,770 off of their October cookies, cakes, cupcakes. Okay, and that's what we're calculating. So 240 plus 2,100 plus 750, zeros in the ones position. 5, 0, 4 is 9, and 7 plus 1 is 8, plus 2 is 10. Carry the 1, and that is $3,090. And we have all zeros in the ones. In the tens, we have 0, 0, and 6. In the hundreds, we have 5 and 3, which is 8. And in the thousands, we have 6 and 1, which is 7. Okay, so we should have gotten 1,770, 3,090, and 7,860. Okay, and now let's do it in the calculator and watch how simple this is. So I'm going to go to my calculator, turn it on, clear the home screen, second matrix, and I'm going to edit A. And I'm going to make it a 3 by 3 this time. So I'm going to say 3 times 3 and put the new values in, which are, just move this over so I can see it. 65, 40, 75. So it's 65, 40, 75, 80, 70, 150, 120, 200, 300. Okay, so there is our number of cookies, cakes, and cupcakes, and it's matrix A. I'm going to go back to second matrix, and I'm going to go over to edit. I'm going to go down to B. I'm going to edit it and make it this 3 by 1. So it's 3, 1, 1, enter. And I'm going to change the values to $3, $30, and 5. So 3, 30. Okay, so there's our two matrices. And now we're going to multiply A times B. So I go to my home screen and hit second matrix A, second matrix B, and hit enter. And we got the same answer. Okay, now the next question is, Enrique and Sophia only want to enter the product if they made from the sale. I'm going to move this back here. Enrique and Sophia only want to enter the profit they made from the sale of each item into their income budget chart. They make 40% profit on the cookies, 20% on the cake, and 30% on the cupcakes. So they don't make the same percentage on each item. Set up a percent profit matrix and multiply the matrix times the income matrix determined in part B. Be sure that the percent matrix has the correct dimensions for multiplication. Okay, so what I want to do for part C is set up a matrix. All right, and we can call it P. Let's just call it P for profit. So the profit matrix, or the percent matrix, I guess, would equal, have these fives here, 40%, 20%, and 30%. Parentheses. All right, so here is our matrix. Remember, you should always say what the dimension is. It's a 1 by 3. Okay. And the number of cupcakes they sold is right here. And the amount of money they made is right here. So we want to now determine how much profit they made with this matrix. So we're going to take, actually we named this n times p. We already named that p. So I don't know. Q, I don't care, it doesn't matter. The book says X, so let's just call it X. Matrix X is our percentage, and we're going to multiply it by our income matrix, which we ended up being n times p. So we let I equal n times p. This is our I matrix. So we're going to multiply I times X. So here's I, here is X, 1770, 3090, and 7860. This is a 3 by 1 matrix. And as you can see, the threes match inside, so we can multiply these, and we're going to get a 1 by 1 matrix, which is going to be their profit. Okay, if I did it the other way around, and we did it backwards, we would have the ones sort of look like this, a 1 by 3 times a 1 by 3, or I'm sorry, not a 1 by 3, oof, 3 by 1. So if I move this matrix over here, it'd be a 3 by 1 matrix times a 1 by 3, and these do match up, but we get a 3 by 3 matrix, and that would not be one value, which is what we're looking for, which is our profit. So you have to think about how you're setting these up, what makes sense in the context of the problem. And we can multiply this because this is a 1 row by 3 matrix, which will give us a 1 by 3 times 3 by 1. These match, giving us a 1 by 1 matrix. So our answer is just going to be one number. Okay, and so let's do that. And so we already have this matrix, and I am now going to multiply this matrix, which is A times B. And I'm just going to put it in my matrix. So let's go down, or actually let's go over to edit first. And whoops, second matrix, over to edit. I want to leave that. And now let's put C as our answer here, which was, actually we could do C as our percentages. And our percentages were 40. So this is a 1 by 3, whoops, delete. 1 by 3 matrix, and it's 0.40 and 0.20, and then finally 0.3. Okay, so there's our matrix C, which is our percentages, and then I go back to second matrix, and we'll use column, or the matrix, do that again, matrix, arrow over to edit, arrow down to D, and we're going to represent D as this 3 by 1. And we're going to put 1,770 in. We're going to put 3090 and 7860. Enter. And now I'm going to multiply matrix C times matrix D. So I go to my home screen, clear, matrix C, matrix D. enter, and we profited $3,684. And what do? We took 0.4 times this plus 0.2 times this plus 0.3 times that. I didn't show my work in this one. I just showed it in the calculator, but it's the same process as up here. All right, so now it says to set up a matrix of expense percentages to determine the total expenses for the online bakery. Okay, so now it says to set up a matrix of expenses. So if this is profit, the expense matrix is going to be 0.6. If profit was 40%, then 60% was expenses. If 20% was profit, then 80% were expenses. If 30% were profit, then 70% were expenses. So there it is. And then what we have to do is multiply that by this matrix here. So we're going to multiply that by my 1,770, 3,096, and 7,860. And what's going to happen there, I'll show my work on this one. This is a 1 by 3. This is a 3 by 1. The 3s match, so I can do it, and I'm going to get a 1 by 1 matrix. So we're going to take, and what we do is 0.60.6 times 1770 plus 0.8 times 3096 plus 0.7 times 7860. Okay, I can do it this way as well. And so it's just 0.6 times 1770, enter, and get 1062. Okay, so this is going to equal 1062 plus 0.8 times 3096. And that's 2,476.80. Okay. And then finally, 0.7 times 7860. Yeah, 5502. And then when I add those three numbers up, 5502 plus 2476.8 plus 1062, I get $9,040.80. That was the expenses. Okay, I made one mistake there. I thought that was 3096. It's 3090. So this is 3090. My apologies there. So 8 times 3090, 0.8 times 3090. I was kind of questioning that when I got pennies. Okay, so this is not 2476.80, it's 2472. So it's 2472. So if I subtract 680 from my total over here, it should be 9036. That's what the answer should be. Okay, hopefully you didn't do the same thing I did. And I'm not going to show that in the calculator. We already know how to do it in the calculator, I hope. And now it says to find the product of this, extend your understanding. So it's probably not a real good idea to use the calculator on this problem simply because it's practicing the procedure. So let's just do it manually. So this is the product. I will do it with the calculator after to check my answer. So here's A and here's B. So A times B is going to equal, for starters, we have to check the dimensions. So this is a 4-row, 3 columns. So that's 4 by 3. And this is a 3-row, 2 column. That's a 3 by 2. The 3s match. So we can do it. We're going to get a 4 by 2 solution, 4 by 3 solution. Whoops, it's supposed to be 2. This is a 3 by 2. So we're going to get a 4 by 2 dimension product matrix. All right. So first thing we do is we focus on the first row, first column, and multiply first times first, middle times middle, last times last. So this is going to equal 3 times -6 plus 5 times 0 plus 2 times 9. That is just my first position of my new matrix. Okay. And then we're going to take and go down to, whoops, they're not separate. So let's just erase this, make them separate. All right. And now we're going to do this one. So it's going to be 1 times -6 plus 1 times 0 plus 0 times 9. Okay, and then we're going to move this down to here. And this is going to be 4 times -6 plus 3 times 0 plus 5 times 9. Okay, and then we move this down. Probably not a bad idea to do it in this process. 2 times -6 plus 4 times 0 plus 6 times 9. Okay, and that is just my first position, first row of my new matrix. Okay, so instead of continuing on here, I'm going to simplify this now. 3 times a -6 is -18. 5 times 0 is 0. 2 times 9 is 18. Okay, and we're adding these. 1 times -6 plus 1 times 0 plus 0 times 9. This is 4 times -6, which is -24, plus 0 plus 9 times 5 is 45. 2 times -6 is -12, plus 0 plus 54. Okay, I'm just going to do the first column first, and -18 plus 0 is -18, plus 18 is 0. So my first position, my 1, 1 position is 0. -6 plus 0 is -6. 24, -24 plus 45 is 21. And 54 minus 12 is 42. Okay, so we're done the first column. 0, -6, 21, 42. I will change colors now just to make it less confusing. So now let's get rid of these. So now what I'm going to do, I'll use green. And now we're going to multiply first row times second column. 3 times -5 plus 5 times 4, let me use parentheses, plus 2 times -3. Okay, and then we're going to move this down, and we're going to do 1 times -5 plus 1 times 4 plus 0 times -3. Okay, move this down. 4 times the -5 plus 3 times 4 plus 5 times -3. Alrighty, and then finally, last one, 2 times -5 plus 4 times 4 plus 6 times -3. Okie dokie. All right. Actually, that all should be up here. I don't know why I wrote it down here. Let me move these. This should be here. Let me just pause this and put it in the right place for you. Okay, so my first one was showing all of my work. My second one is my multiplication. So 3 times -5 is -15, plus 5 times 4 is 20, plus 2 times -3 is -6. 1 times -5 plus 1 times 4 plus 0 times -3. 4 times -5 plus 3 times 4 plus 5 times -3. Okay, and 2 times -5 plus 4 times 4 plus 6 times -3. Okie dokie. And now we're just going to add -15 plus 20 is 5, minus 6 is -1. -5 plus 4 plus 0, -1. -20 plus 12, -8, plus a -15, -23. -10 plus 6 is 6, minus 18 is -12. Okay, so there is my matrix solution. And now I'm going to do it in my calculator to check. Okay, so I'm just entering this matrix. Let's erase these. And we're going to enter them as A and B. So I'm just going to go into my calculator. Whoops, don't go over there. Get back. All right, so I'm going to turn the calculator on, clear, second matrix, edit, enter, and it is a 4 by 3, 4 by 3, and we're going to enter 3, enter, 5, enter, 2, enter, 1, 1, 0, 4, 3, 5, 2, 4, 6. Okay, so this is this matrix A. Go back to matrices, arrow over to edit, down to B, enter, and this is a 3 by 2. Whoops, delete, arrow over here, 2, enter, and it's -6, -5, 0, 4, 9, -3. Okay, so now we're just going to do A times B. So go to our home screen, second matrix 1 for A, second matrix 2 for B, enter, 0, -1, -6, -1, 21, -23, 42, -12. Beautiful. Okay, so there it is. That is how you do matrix multiplication. That is how you check your matrix multiplication. And that is the end of chapter 11.5. Thanks for watching and have a great day.